My dear friends, welcome to Rajashekar classes on applied data science with Python. This is lecture number 295. In this lecture, we will try to understand KNN classification algorithm using scikit-learn. Before understanding this implementation details, let me recall few distances. There are distances like Minkowski distance, Manhattan distance, Euclidean distance. In future classes, I will discuss in detail about these distances. Time being, just let me assume I have a point P whose let me say these coordinates are x11, x12, so on. Let me say x1n. This is one point. Let me say there is another point x21, x22, so on x2n. If there are 2 points P and Q, how can I find Minkowski distance? This is the formula, sigma I equal to 1 to d x1i minus x2i whole to the power of mod whole to the power of p, then I must keep whole to the power of 1 by p. If I keep p equal to 1, if I say p equal to 1, this distance will become Manhattan distance. If I keep p equal to, I will get Euclidean distance, that is nothing but x11 minus x21 whole square plus x12 minus x22 whole square plus so on x1n minus x2n whole square under root I must keep. This is Euclidean distance. You might have seen in many occasions. Anyway, I will discuss in detail about these distances. I will derive things. I will discuss. We will derive these distances in future classes. Time being, just understand this Manhattan distance is special case of Minkowski distance. If you keep p equal to 1, you will get Manhattan distance. If you keep p equal to, you will get Euclidean distance. As I told you, I will discuss in detail about these particular distances. Now, we will use the KNN classification that is implemented in scikit-learn. sklearn, I can say, people used to call this one as sklearn. sklearn is basically, I can say, sklearn basically means scikit-learn. sklearn means, I can say, it is scikit-learn. Now let's go through this function. What is this function? K-neighbors classifier function. We will try to understand this particular function. We will try to understand its parameters and see very now let's go through this function and see very simple example and see multiple cases here. Parameters here, just see, my first parameter is n underscore neighbors. What does it mean? N underscore neighbor is number of neighbors. I can say this is number of neighbors, isn't it? That is basically number of neighbors, which is nothing but k, isn't it? Which is nothing but, this is k in KNN, which is nothing but k, that is number of neighbors. The default value of k is 5. We can change this neighbors. You can change this value to whatever number you want. You can change according to your convenience, but default value is 5. We can change it to whatever number you want. This is basically k in, I can say, this is basically, I can say, k in k nearest neighborhood algorithm. The second parameter, something called weights. What is this weights? We will try to understand what is this second parameter. What is my second parameter? Second parameter is called weights. Weights is basically nothing but whatever, whether, let me say like this, weights basically nothing but whether you want a uniform weighted KNN in which all the points in neighborhood are weighted equally. Remember, we discussed weighted KNN. Just recall, I already recorded lecture on weighted KNN. What is this weighted KNN? Just I kindly request you to refer lecture number 288, in which lecture number 288, in which I discussed about weighted KNN, where for a given point you can give weights corresponding to that point. I can give weights inversely proportional to the distance. So when I say weights equal to distance, there are two options, isn't it? Weights may be uniform, weights may be distance. I already discussed what is uniform. If I say weights equal to distance, if I keep this distance parameter, what it does a weighted KNN. If I say in this place of weights, if I say weights equal to distance, what will it do? What it does? It does weighted KNN. It does weighted KNN, which we discussed. It does weighted KNN, and weight given to each point is inverse of the distance. We discussed about weighted KNN in lecture number 288. The default is, by default, weights equal to uniform, which means each point, uniform means what? Which means each point get the same weight. Each point get the same weight. Each point get the same weight. That's the meaning of uniform, isn't it? I will repeat. The default is uniform, which means each point get the same weightage, but you can make it distance based. The third parameter here is algorithm. What is this algorithm? We will try to understand what is the meaning of algorithm. If you carefully observe this one, it has got multiple options: auto, ball tree, KD tree, brute, and default one is here auto, isn't it? The third parameter here is the algorithm. How do you want to compute your KNN? What is the use of this algorithm? How do you want to compute? How do you want to compute your KNN? That's what it says. If you see the algorithm, there are multiple algorithms. There is ball tree. We discussed about ball tree, isn't it? Ball tree, it's a type of KD tree. We discussed in variants of KD tree, isn't it? There are multiple algorithms. There is a ball tree, which is type of KD tree, which is modification of KD tree. I can say ball tree is modification of KD tree. There is a ball tree which is type of KD tree, which is modification to KD tree. So KD tree that we discussed, I already discussed about KD tree, isn't it? Brute force, there is another option, algorithm equal to, if I say brute force is basically simplest brute force search, isn't it? There is a fourth parameter called auto. What does it mean? There is another parameter. Let me say like this. This is the parameter. I can say there is a parameter called auto. What auto does based on the data? Let me say like this. Based on the data, it will pick the best algorithm. It will pick the best algorithm. If the dimension is low, let me say like this. If the dimension is low, we already discussed what is the dimension in my previous lectures. If the dimension is low, then probably it will pick up KD tree. KD tree works well in the case of low dimensions. If D equal to 2, D equal to 3, D equal to 4, something like that. Even if your data is uniformly distributed, if dimension is low, probably it may pick up KD tree. If the data is small, if the data set itself small, let me say like this. if the data itself is small, let me say like this, if the data itself is small, it will pick up brute force. It may pick up brute force. The default value is auto itself. If you leave it to auto, the algorithm will figure out whether the KD tree is best algorithm, whether a ball tree is best algorithm, whether a brute force is best algorithm. If you have KD tree like data structure, we already discussed what is KD tree, isn't it? We already discussed how to find one nearest neighbors by using KD tree. What is the leaf size? We have another parameter. We will try to understand next parameter, just leaf size. What does it mean? We will try to understand what is leaf size. Leaf size is basically number of points that you have in leaf. What does it mean? What is leaf size? Number of points. I request you to refer my lecture on KD tree so that you can understand what is leaf tree. Let me say leaf size is basically number of points. Number of points that you have in a leaf. That is leaf size. Number of points that you have in a leaf. Of course, your leaf size could impact a lot of other things. It could take more memory. Depending on your leaf size, it could take more memory. It could take less memory. I can say like this, it could take more memory, or it could take less memory, or it could take more computing time, or it may take less computing time. I can say this leaf size will impact memory consumption, also computing time. Isn't it? I will repeat. It could take more memory, or it could take less memory. It could take more compute or less compute depending on leaf size. Just see here what is my P. Just see P. What does it mean? What is the meaning of this one? P here basically, P here basically the power. The P is basically the power of the Minkowski distance. Minkowski distance. In first slide only, we discussed what is Minkowski distance, what is Manhattan distance, what is Euclidean distance. As I told you, I will discuss in detail about those distance. Time being, just understand that P here is basically power of the Minkowski distance. The default value of P is equal to 2. What is P equal to 2? P equal to 2 is L2 norm, isn't it? L2 is nothing but Euclidean distance. By default, this distance is as P equal to, as I discussed in first slide, that is L2 norm. That is P equal to means, P equal to 1 means we were getting that Manhattan distance. P equal to 2 means you will get Euclidean distance. Here default value of P is equal to, therefore our distance is Euclidean distance. The default metric is Minkowski. Default metric is Minkowski with P equal to 2. What is the Minkowski with P equal to? It's nothing but L2 distance. It is nothing but L2 distance. L2 distance is nothing but Euclidean distance. L2 distance is nothing but, I can say it is Euclidean distance. The default is Euclidean distance. But if you make P equal to 1, as I discussed in my first slide, if you make P equal to 1, you get Manhattan distance. You can change metric to any function. You can have huge set of matrices that you can choose. The default one is, as I told you, default is P equal to 2. P equal to 2 means what? It is Euclidean distance. You can have other parameters, like even if you want, you can parallelize the jobs. There is something like KNN, and you can parallelize these jobs. You can say multi-core. If you have multi-core system, you can always parallelize the jobs. The default value is 1. The default value of n underscore jobs equal to 1. What does it mean? 1 means, what is the meaning of 1? Which means it is a single job. 1 means it is a single job. If you just set to -1, it will try to parallelize the jobs. If you have multi-core system, you can parallelize the jobs, which can speed up the things. So these are all the parameters that you get. I will continue my discussion in my next lecture about this KNN algorithm using scikit-learn. Thank you very much.